Okay, so we have all the validity to run the arch model because there is a clustering volatility and there is arch effect that we have already tested. So now we can run the arch model from here. Okay, so I go to estimate. Here is estimate, right? I click on it, and then here I click on it. Then I choose arch, autoregressive, conditional heteroscedasticity that I'm checking here. I can check here. Autoregressive, conditional heteroscedasticity. I choose this one. Okay, then I can run it. Here you can see our mean model. It is the mean model, right? Mean model, and where IBR is the dependent variable, right? Here I put IBR, C, and PBR, right? You can see we have this. This is the mean model, right? You can see mean here, right? Mean model. Mean model here we can see, and here suppose I take Garch and Torch, right? So I choose Arch 1 and Garch 1. So I choose Arch 1 and Garch 1 to run this model, right? And here, so I choose Arch and Garch, and here the variance independent variable, variance regressor, here I put two variables. One is BSR and one is BBR. What is BSR? Bangladesh stock return. And what is BBR? Bangladesh bond return. Okay, I can make the whole thing zoom, right? No, sorry. And here I choose Arch M, right? Here I choose Arch M. So none. I choose here standard deviation, right? Standard deviation. So the whole things becomes the whole things become the Garch Arch M model. And suppose here normal Gaussian, suppose I choose here student T with fixed degree of freedom, that I choose here, right? So this is my model. This is my model, and sample size is 300, right? So that is my model. So whole thing I can make it zoom. I make it zoom. You can see. You can see from sorry. You can see the whole thing zoom. So this is the main equation, right? It is the main equation, and you can see that is standard deviation, Arch and M. And then you can see here, I can see this one, I'm sorry. And here Arch and Garch, this Arch and Garch 1. And here I choose student with T fixed degree of freedom, that is 10. And here you can see variance regressor, that is BSR and BBR. So that is the zoom result. Okay, I'm saying again, I'm showing again mean equation. There is IBR, C, and PBR. So that is Indian bond return and Pakistan bond return, this one. And here Arch M, So here I choose standard deviation. Then here Garch and Tarch, I choose one arch and one Garch. Then variance regressor, I choose BSR and BBR. Then error distribution, I choose students T with fixed degree of freedom. So these are the things I have chosen, and our sample size is 200, right? That we know. The model. We can now run the models and we see what happens. So I press on the OK. So the result is coming up. Just wait 1 minute. Okay, this is the outcomes of the models, right? This is the outcomes of the models, right? So our dependent variable is Indian bond return, that is here. And here are two models. So the first model, this one is called mean model, mean equation model, and the second one is the variance equation model, right? This one, variance equation model, that is the second model in here. Okay, and here what is happening, you can see from here, that is okay, here we check one by one. Okay, what about this one? Square root of Garch, that means standard deviation of the return. This one is the standard deviation of the return of Indian bond return. I am writing here. I must talk about this one first. Okay, what is this one? Square root of this one. This one means, just I am saying, that is the standard deviation of Indian bond return. Meaning that IBR, and IBR is the dependent variable. Meaning that, what does mean by standard deviation? Standard deviation means actually risk of the Indian bond return, that is IBR. So standard deviation is the risk of the Indian bond return. So this variable SQRT Garch actually is the risk of the Indian bond return. Okay, and the sign of it, the sign is positive. You can see the sign is positive. The sign of the coefficient is positive, right? And the p-value is 0, meaning that p-value is significant. So it is positive and significant, meaning that Indian bond return, it is a risky asset. Because the sign is positive and it is significant. So Indian bond return, that this asset is risky, and that follows the theory, right? That means standard deviation is the risk of a asset, right? So meaning that standard deviation goes up, risk also goes up, right? Volatility also goes up. Standard deviation is the risk, right? So more the standard deviation, more the volatility, more the risky asset it is. Okay. So this part is done. This part talk about the mean model, that is this one. Okay, then what about the variance equation, right? Variance equation, it is here. Okay, in this variance equation, you can see from here, okay, what is receipt arch effect and what is Garch, that is Garch effect. Okay, arch effect, is it this one, the coefficient, and the p-value is less than 5%, meaning that arch effect can influence the volatility of Indian bond return, that is IBR. Okay, what is called this one? Receipt, which is called arch effect. Arch effect means, actually by definition we can say that arch effect means we can say we can say that previous days return information about volatility. Previous days return information about volatility, or we can say previous periods squared residual, right, volatility. So that is arch effect. That means volatility in the Garch. What is Garch? Volatility in the IBR, right? Volatility in the IBR is influenced by arch. What is arch? Arch is the internal effect of IBR. Internal effect, meaning that volatility of the Indian bond return, that is the internal cause, not external cause, internal cause. Okay, and what about the Garch? Garch is also internal cause of the volatility of the Indian bond return. Is it significant, the Garch? Yes, it is significant because the p-value is less than 5%. So what is Garch effect? Garch effect means previous days residual variance or volatility of Indian bond return. I am saying again, previous days residual variance or volatility of Indian bond return. So that is called Garch effect, and that is also internal cause for the volatility of Indian bond return, that is IBR. So receipt, which is arch, and Garch, both are the causes of the internal causes. Both are the internal causes of the volatility of the Indian bond return. And both Arch and Garch effect are significant, meaning that internal causes are significant to explain the volatility of the Indian bond return. Okay, that is the internal cause. But what about external cause that affect the volatility of the Indian bond return? Okay, in this regard, there are two external volatility. One is BSR and one is BBR. Okay, what is BSR? Bangladesh stock return. That is the external cause. Is it significant? No, because the p-value is more than 5%. So Bangladesh stock return cannot affect the Indian bond return volatility. Then what about BBR? Bangladesh bond return. That is also external cause to influence the volatility of Indian bond return. Is it significant? Yes. You can see the p-value is less than 5%. So it is so the BBR influence, that means volatility of BBR can influence the volatility of IBR, but it influences negatively. You can see the sign is negative. So BBR influence IBR but negatively because the coefficient is negative. So that is the explanation of this Arch M model. So meaning that what is the gist of this model? Arch and Garch influence the volatility of the Indian bond return, which are the internal causes of the volatility of the Indian bond return. And BBR is also influence IBR but negatively, that we can see from here. Okay. Then we check how is the model. Then we check the Akaika information criteria and Schwarz information criteria. And we can see from here, we just noted down our Akaika value and Schwarz value so that we can compare it later with other model. Because what is the guideline? The guideline is lower the Akaika or Schwarz value, then better the model all the time. Okay, so here Akaika, how much? Akaike is how much value? I will write it down, minus 7.36, right? And Schwarz criteria, SCH, what is the value? The Schwarz is 7.26 minus 7.26, right? So that is the two things, Akaika and Schwarz. And here we are using student with fixed degree of freedom, right? That is the error distribution we are using, student with fixed DF, degree of freedom, and here we have chosen 10, right? Okay, and it is the result of this model when we use the student with fixed degree of freedom. Okay, then we check whether whether this model that we have estimated, is it good model or bad model, meaning that diagnostic checking we can do it, right? That means whether this model has arch effect or not, or whether this model has serial correlation or not, meaning that we can do the diagnostic checking in other way, diagnostic checking, right? That we can do now, right? Okay, first we check, sorry, we have gone some. Okay, first we check whether it has arch effect or not. That we check first, right? Arch effect. Okay, what is to be done? Arch, I go to view, then residual diagnostic, then I choose arch LM test, right? I click here. Okay, arch, I choose 1, right? Number of lags, I choose 1. Then I choose arch here, click here. You can see this is the arch test. Observed R squared p value. How much is the p value? 87.95%, which is more than 5%. So we cannot reject null hypothesis, meaning that, and what is our null hypothesis? The null hypothesis is there is no arch effect. So we cannot reject it because the p-value is more than 5%. So we are happy about this model because here is no arch effect. Okay, then we check about the serial correlation, whether any serial correlation or not in the Garch model. So I click view, residual diagnostic, and I check correlogram squared residual, right? Correlogram squared residuals, I click here, and suppose I choose 36 lakhs. I choose 36 lakhs and I click here, right? So this is the outcome of the result, right? You can see the Q statistics and corresponding p-value, right? You can see. And what is the null hypothesis? Null is there is no serial correlations. That is the null. There is no serial correlation. That is null. And you can see the p-values, right? You can see the p-values are here, right? Okay, the p-values are here. Okay, the p-values are here, but the problem is that here we can reject the null, right? But here is not, right? Here we can reject the null, but here, suppose here we can reject the null. That is the problem comes up, right? So that is the bad side of the model. Probably there is serial correlation in the models. So that is the bad side of the model, that there is serial correlations, but this model has no arch effect, but there is serial correlation. So normally we cannot accept this model, right? But suppose, but one is good, that there is no arch effect, but there is serial correlation. That is the bad side of this model, right? Because we can reject the p-value, right? We can reject the p-value. You can see the results are very small. So meaning that there is serial correlation of this model. So here is no arch, that is understood, but serial correlation exists. So that is the bad side of this model, right? no arch, but there is serial correlation. That is the bad side of this model. So okay, so this is done.